Right, so let's sketch the graph representing each of the following relations and state whether each is discrete or continuous. So we've got y equals x squared, which we should recognize as a parabola. However, it says where x is an element of 1, 2, 3, and 4. Notice there are very specific discrete values of x for which this function is valid. So I'm going to sketch those as points on my graph. X squared, I need to go up to 16, so 4, 8, 16. All right, so when x equals 1, y is equal to 1 squared, and so I've got a point over here at 1, 1. When x equals 2, I have 2 squared, which is 4, so I have 0.24. When x equals 3, well, 3 squared is 9, just past the 8 over there, so I'm going to have 3 and 9. And when x equals 4, 4 squared is 16. And notice I'm not going to join the dots. These are discrete points. There are only 4 points where this function is valid. All right, the next one says y equals 2x plus 1, where x is an element of all the real numbers. Okay, so that means that any value of x is valid, and I'm going to sketch this. It's a linear function, so 1, 2, 3, and 1, 2, 3, and 4. My y-intercept is at 1, and my gradient is positive 2 over 1. That gives me my second point over there, and I can sketch a straight line through those 2 points. Hopefully it'll jump through it. There we go. Okay, so that's y equals 2x plus 1. Let's have a quick look at example 16. Remember that a function has only got one y value for any x value, and we need to figure out whether these are functions or not. Okay, so if I look here, these points, there's 0.13, 24, and 15. Excuse me. For x equals 1, I have got 2 different y values, so that means it is not a function. If I look at this one, y equals x plus 3, x minus 1, x minus 6, well, we all know that that's a cubic, and we know that a cubic is a function. With our vertical line test, it would only cut it once, so there is only one y value for each x value, and that is a function. Y equals x squared, again, that's a parabola. We know that if we did our vertical line test, we would only get one y value for each x value, so that is also a function. And then x equals y squared. Now that's an interesting one, because, well, if I take the square root on both sides, I'm going to get a positive and a negative value. So I'm going to end up with 2 values of x for each value of, 2 y values for each value of x, and so therefore that is not a function. And we're going to see that's actually a sideways parabola.